Okay, let's talk about inequalities now. This is the second part of chapter section 11.4. So when we're discussing inequalities, we have a couple symbols that we commonly use. I'm going to paste these here. So we're all familiar with the equal sign. So we could represent something in an equation like 3 equals 2 plus 1. But now we have another sign here called the less than sign. And it's like an angle on its side with the vertex pointing to the left. So less than sign means something is less than something else. So 3 is less than, let's say, choose different numbers here, 8 plus 1, or 3 is less than 9. That makes perfect sense. And conversely, we can use the greater than sign. So 3 is greater than 1 plus 1, or 2. So that's how we could use these signs. We can expand this into less than or equal than, or greater than or equal than. So it's one or the other in these cases. And let's manipulate some of these ideas graphically to see how they might come into play with some of the stuff we've learned so far. So here I've drawn a plot of a line in orange on a Cartesian axis, and this line, let's say the point here that it crosses, it's a horizontal line, and the point that it crosses the y-axis is 4. So there's an equation to this line, y equals 4. So that's the equation to the line, y equals 4 no matter what value x is. X is, doesn't come into play in this equation, so y equals 4. Well, I might ask the question, solve this inequality graphically Oh, wow. Getting some lag here. Solve graphically the equation y is greater than 4. Well, how would I do that? Well, to solve this graphically, the places where y is greater than 4, if I choose some x value, where is y greater than 4? Well, it's going to be every spot. It's going to be someplace up here. These spots, anything up here, if I choose like -1 here, or let's make this -2 so it kind of fits better in our, if I choose -2 here, any of these, anything above this line will produce a y value greater than 4. For example, if I choose this point here, which is the point -2, 5, that's greater than 4. So what we could do if we're going to solve this graphically is we'd want to shade in this whole area up here over the y equals 4 line. So y equals 4, the equation y equals 4, it acts as a boundary. So suppose I wanted to ask the question, y is less than 1. How would I represent that over here? Well, the first thing I'm going to do is I'm going to recognize that y equals 1 is the boundary there. And let me go ahead and plot that boundary. So y equals 1, let's say, is down here somewhere. I'll plot that boundary. And I don't like the way that doing the lines in this is so cumbersome. So that's y equals 1. And if I want to plot y is less than 1, I would then hash in everything below this, because that's y represents y is less than 1. Suppose I were to modify this and say y is less than or equal to 1. Again, y equals 1 is going to be our boundary in this situation, but now I have to actually include this line here of y equals 1. So this line is y equals 1. I have to include this line now in my graphical representation of this relationship. Okay, so that's our basic methodology. Whenever we have to solve an inequality graphically, what we're going to do is figure out where the boundary is and then determine which side of that boundary we need to shade, depending on what our relation is. So these are kind of intuitive problems. Let's get a little more complicated. What if I were to ask this question, and ask you to solve this? 3x minus y is greater than or equal to 5. Well, we would approach this in the same way. The first thing we're going to do is we're going to find the boundary here. And what is our boundary? Our boundary is 3x minus y equals 5. And I can rewrite this maybe 3x minus 5 equals y. If you wanted to, you don't need to do that, but you might find it easier to plot this line, because that's what we're going to do next. We're going to plot this boundary. Which means I'll need to set up a table, or I may want to. You don't have to. Maybe you do this in your head. So let's start throwing in some values. Let's say when x is 0, y equals minus 5. When x is 2, well, let's go 1 next. When x is 1, this is 1 times 3 is 3. 3 minus 5 is minus 2. Y is minus 2. And when x is 2, we've got 6 minus 5. Y is 1. So I've gone ahead and sketched in some numbers on our Cartesian system. So when x is 0, y is minus 5. That's this point. When x is 1, y is minus 2. Again, I'm going to draw these points big to take into account my error in my scale. And if you have a perfect scale, you won't have to make your dots as big as I do. And when x is 2, y is 1. So big dots here, big dots here. So I have this then. I have this as a line. And that's my boundary on this relationship. Move it around just a tad. Make this one a little bigger, so it all looks kosher. So that's my boundary line. So I could say this is my equation. Y equals 3x minus 5. That's the equation. That's my boundary line. Now the question is, how do we figure out this inequality? Well, we can do this by taking test points and seeing if the equation is valid. For example, let's choose a test point over here, 0, 0. So when x is 0, so let's do these tests. So when x is 0 and y is 0, what do we get for our equation? Well, we've got 0 is greater than or equal to 5. Well, that doesn't satisfy our equation. So things don't work on this side of the boundary line to satisfy our equation. Let's try 3 and y equals 0. So let's try this point over here, 3, 0. And I'm choosing a 0 here because it's going to be easy for me to calculate. So now I've got 3 times 3 is 9, minus 0 is 9, And 9, in fact, is greater than or equal to 5. So yes. So we've determined then that graphically speaking, this area over here on this side of the line satisfies this equation. And since it's greater than or equal to, we also have to include this line. We wouldn't include the line if we didn't have that or equal to part to it, but we do because we do have that. So go ahead and check some other points, and you'll see that this is only satisfied over on this side of the line. So if that comes up on your test, that's how you're going to solve those sorts of problems.